to my channel. In this week's workshop video, I'm going to show you the reaction mechanism with examples on Favourskii rearrangement. So that is what we'll be talking about today, Favourskii's rearrangement. So this is our topic for today, Favourskii's rearrangement. So I'll be showing you the mechanism with other examples too. This rearrangement occurs when an alpha haloketone reacts in the presence of a base to give you either carboxylic acid, ester, that is when you are using alkyoxide, it reacts to give you ester, and also it reacts to give you amine. So for this video, those are the three bases we are going to use. So let me show you how this reaction starts. Suppose we have this. We have a hydrogen here. Okay, this is a haloketone compound here. So to react with an OH, and this we attract this proton here to give you this COBr. Then this bond here, we attack this carbon here, and you get this this Br. Now this bond here will attack this carbon to give you the intermediate, of this reaction. It attacked this carbon, so to give you the intermediate. When it attacked, this will be kicked off, bromine will be kicked off to give you this intermediate of the reaction. So this intermediate now, the base will attack the intermediate and you get the desired product, which could be carboxylic acid and ester, that is when you are reacting with alkyoxide or amine. So let us react with hydroxyl. So our hydroxyl will attack this place here. So when it attacks, this is what we'll get. It attacks this carbon, and this carbon now will become unstable. According to octet rule, it's supposed to be bonded to 4 bonds. It's supposed to have 4 bonds here, but here now it's having 5. 1, 2, 3, 4, and this one 5. So it will be unstable. So for us to make it stable, we are going to make this bond go out. This bond, we attack this carbon, making this place a nucleophile. So this is what we are going to get from that. Okay, so when it attacks and that displays, we get this is our ketone. Now the hydroxyl group. Now this is our methyl group here, but this is CH2 because of this particular bonds that attack this carbon. So it will be CH2. So it is unstable. So for us to make it stable, this electron here will attract this proton. So this proton will attack this electron, and we have our CH3, which is our desired product. CH3, or this could be the same thing as CH2, this, but for this video we are going to use CH3 for there. Now this carbon here is stable, so this is our desired product. Now we have our carboxylic acid because we reacted with this base, with hydroxyl as a base. So this is the first part. The reaction proceeds with an alpha haloketone to form a propanone intermediate for the base to attack, Then after the attack, we get our desired product, which is carboxylic acid. So let me show you some other examples, because this workshop we are going to look at examples. So let me show you an example on this video for ring contraction, how Favourskii rearrangement works for ring contraction. So before I will do that, I would like you to pause the video and hit on the subscribe button if you've not subscribed to my channel. If you have, please hit on the like or the thumbs up button there, so we can continue doing videos like this. So I'm going to show you what happens for ring contraction. Okay, Favourskii rearrangement reaction, this is what happens. Like I said before, the reaction proceeds when an alpha haloketone reacts in the presence of a base to give you your desired product. So we are going to use either amine, hydroxyl, or alkyoxide. That is what we are going to use for this video. So let us draw our ring. Suppose we are using alpha haloketone. Let us say we are using this. Okay, chlorine ketone. Okay, this is alpha chlorohexanone. That is the name of that compound there, alpha chlorohexanone. So we want to react this compound and see how Favourskii's rearrangement works for this particular compound. So normally the reaction starts with OH. So this OH here will attract this proton, and this place will be open. So we get this Cl. Now this place now, this bond now is left. So this bond will attack this carbon here, and chlorine will be kicked off. When chlorine is kicked off, we get our intermediate. Normally, like I said before, our normal intermediate is cyclopropanone, of which we are saying here this is our intermediate. Cyclopropanone is our intermediate. So from the intermediate now we react our base. Suppose we are using alkyoxide, OR or RO. We are using alkyoxide as our base. If we are using alkyoxide as our base, it will attack this carbon here, and when it attacks this carbon, the carbon now obeys octet rule for it to be stable. So when it attacks, it kicks off this bond here, making this place negatively charged. So this is what happens when that proceeds. The ring is now open. The ring is now open, so it happens this way. We have a 5-membered ring now. We have a 5-membered ring now, making this place negatively charged. This is the ketone, and we have our ester. So this is the alkyoxide group. When you see alkyoxide and a ketone reacting together, you get ester. So this is our ester, but we still have a negative charge here, so we are going to treat it with water, with H2O, and water attracts that negative charge, and we get our desired product. And this is ester. Remember what I said, when you react it with the base, you can either get ester, carboxylic acid, or an amine. So we reacted with an alkyoxide as a base. Attacking this intermediate, we got our ester. So this is Favourskii's rearrangement reaction. So suppose we are reacting with let me say OH. Let us react with OH. Now it will still attack this place. It will obey octet rule. This bond will attack here, making this place negatively charged. But this time around, we get our OH here. We have our carboxylic acid. OH, you treat it with water and you get your carboxylic acid. This is also another example. Now let me show you one example before we go. So suppose you are reacting with amine or amine, as some pronounce it, amine, and we are reacting with amine, RNH. Okay, we are reacting with amine. This is what happens. The normal thing happens, it will attack and this bond will be kicked off to this carbon, making it negatively charged. You treat it with water, you get your RNH. You come here, you get your amine. So that is it. So this is how the reaction of Favourskii proceeds when you react with a base. To recap, the reaction starts with the attack of an OH to attract a proton from the alpha cyclohexanone or propanone, whatever, the alpha cyclo or haloketone. When it attracts the proton, you get your intermediates. From your intermediates, you react with a base. Then from the base, you get your desired product. So that is Favourskii's rearrangement reaction. So thank you very much for watching the video to the end. Hope you subscribe to my channel so that we continue working on stuffs like this. See you next week.